Good day, future engineers. I'm Engineer Darwin Tacobanza, and today we will talk about calculator techniques that you can use in solving engineering problems. Electrical wires are essential part of supplying power and distributing establishments. Wire, just like any other material, are subjected not only to mechanical stress but losses due to heat. Differential equations are useful to model this phenomenon of heating and cooling. Allow me to read the problem. An electrical wire supplying power is experiencing a winter season that allows it to cool at a given rate. dH over dt is equal to negative 0.05 multiplied by H minus 70 degrees Fahrenheit, where H represents the temperature of the wire, while the variable T has time in minutes. If the wire was at 120 degrees Fahrenheit initially, what will be its temperature after 10 minutes? So this problem falls on a differential equation, which has a time rates problem. On the next slide, you will see the choices for this given problem. To solve for this problem using a calculator technique, we can set the limits of t from 0 to 10, which is from 0 to 10 minutes as stated in the given, while h is from x to 120 degrees Fahrenheit. X is the variable or the value that we are asked to find. Let's now proceed with the computation. Now that we have a working equation on the given problem, we can use calculator to compute and find the value of x. Though in this format, this cannot be solvable using the shift calculate functionality of our calculator. We can simplify the equation so that it can be solvable. To do that, let's simplify the left and the right side of the equation. Let's check on the right side first. The integral of dt from 0 to 10 as its limits can be simplified as t with the limits of 0 to 10. So the value of this will be 10 on the right side. So let's input this information. Is equal to 10 on our right side. Then on the left side, since the shift solve capability of the calculator cannot perform the integral computation with x as one of its limits, we can solve this left side by computing the antiderivative of the function. This equation dh over negative 0.05 quantity h minus 70 is a natural logarithm. So to do that and input this information in our calculator, that is 1 over negative 0.05 as a constant. Then the antiderivative is ln or natural logarithm of h minus 70 from limits 120 up to x. So to evaluate this, that is ln of variable x. So let's have variable x here, minus 70 for the first or the upper limit, minus the natural logarithm ln of 120 minus 70. So once everything is ready, let's press shift, then solve. Solve for the value of x. This will give us the correct answer. So the temperature is 100 degrees Celsius, which is the option here on the next slide. Thank you for listening, future engineers. I hope that you learned something about the calculator technique that can be used in solving engineering problems. See you on the next video.